We introduced RESAnything, an attribute prompting-based open vocabulary and zero-shot method for arbitrary referring expression segmentation. Referring expression segmentation maps linguistic descriptions to pixel-level regions and images. Traditional vanilla referring segmentation handles straightforward cases, like identifying person on left as shown in the orange highlight, or glide flopping around on right as shown in the green highlight. More complex reasoning segmentation requires logical inference rather than direct object references. For example, something that the animals are tied to will identify a central pole, requiring understanding of spatial and functional relationships. However, a critical research gap exists when handling more abstract, part-level references. Consider part-level expressions like default function, oval cut diamond, or 19-gram protein. These expressions require understanding not just logical relationships, but also implicit properties within specific parts that may not be visually obvious. This task addresses a key challenge in Amazon's e-commerce platform. Customers struggle to verify product features described in text within product images. This creates an opportunity to enhance shopping by automatically connecting textual description to visual elements. We call this task arbitrary referring segmentation, as it encompasses a broad spectrum of referring expressions. Where previous methods mainly focus on object-level expressions, our proposed method, RESAnything, advances beyond this limitation to handle part-level semantic labels, alongside implicit references like material, style, function, and packaging information, all in a zero-shot manner. Our proposed method, RESAnything, leverages chain-of-thought reasoning. To enable effective reasoning between the input expressions and segmentation proposals, we employ attribute prompting to generate two detailed descriptions, the reference text and candidate text. Firstly, we leverage multimodal large language model instructed by reference text prompt to generate the reference text, which serves as an extended visual description of the input expression. This reference text provides more concrete visual attributes for challenging expressions, particularly for part-level semantic labels and functionality or feature-based descriptions. Secondly, we employ SEM, a state-of-the-art off-the-shelf image segmentation model to obtain the max proposals from the input image. After filtering out duplicate and tiny segmentations, we use visual prompts such as bounding boxes or max images to provide distinct visual representation of these max proposals. Lastly, we utilize a multimodal large language model to generate corresponding candidate tags for each segmentation proposal. It processes the visual prompts and candidate text prompt to produce descriptions that mirror the format of the reference text. The generated reference text and candidate text allow us to assess the similarity between the input expressions and the max proposal much more effectively. Now, we perform the text-to-text and text-to-image comparison to obtain several metrics for the selection. For text-to-text comparison, we first evaluate the similarity between the reference text describing the input expression and the candidate text describing the max proposals. We use the text-to-text comparison prompt to guide a multimodal large language model for a binary yes or no decision. To disambiguate multiple proposals with yes response, we further employ CLIP to generate a scalar similarity score. While the text-to-text metrics already enable good candidate selection, potential errors during candidate text generation could degrade their performance. To alleviate this, we further perform text-to-image comparisons between the reference text and the max-cropped visual prompt. Similar to text-to-text comparison, we use a multimodal large language model-generated binary decision, followed by a CLIP-generated scalar score. The final grouping and selection process evaluates the compute metrics to identify the optimal max candidate that matches the input expression. Our selection algorithm identifies candidates based on either positive decisions or highest cumulative CLIP scores, incorporating mass grouping and priority ordering. For the complete technical details of this selection process, we refer readers to our paper and supplementary materials. We evaluate our method RESAnything on vanilla reference segmentation benchmarks. As shown in this table, our method significantly outperforms the existing zero-shot approaches, achieving comparable results with early supervised methods like VLT. From randomly selected qualitative results, RESAnything generates fine-grained segmentation marks of the input query. We further evaluate RESAnything on reasoning segmentation task, the RESAnything benchmark. Our method achieves state-of-the-art performance surpassing previous supervised methods, which require fine-tuning on reasoning tasks or extensive training data. From qualitative results, our method demonstrates the best performance in locating the target and output precise segmentations. To evaluate on arbitrary referring expression segmentation, we propose ABO image address benchmark, which is built on the ABO image dataset. It contains more challenging reference expressions targeting material, design, function, and packaging label. The benchmark comprises almost 2,500 images from 565 product types with almost 3,000 referring expressions. Our method RESAnything significantly outperforming other methods in both metrics, demonstrating our method's strong capability in handling complex reasoning queries. Qualitative results further visualize the power of our method. Here's key takeaways of our work. Firstly, we introduced the first zero-shot and multimodal large language model-based open vocabulary referring expression segmentation method, targeting input expressions that are more general than those addressed by prior works. Secondly, we propose a method, RESAnything, which is based on novel idea of attribute prompting as a means for chain-of-thought analysis to achieve state-of-the-art performance on both object and part-level reasoning expression segmentation tasks. Lastly, we introduced a new benchmark dataset, ABO image arrays, which is built upon ABO to assess part-level arbitrary referring expression segmentation solutions. Please refer to our paper for more information and results. Thank you.